In this video, we will be looking at electrical circuits. This video will be specific for grade 10. However, it is applicable in grade 11 and grade 12 because not much changes in electrical circuits from grade 10 to grade 12. Now, this video is aimed at an exam level question. Okay, let's get started. So, generally, you will be given an electric circuit, right? And they will give you a bit of extra information for the circuit. So here they say, in the circuit below, each cell has a potential difference of 2 volts. Now, before we do anything else, we just need to note that each cell has a potential difference of 2 volts. That means that if we have 1, 2, 3, 4 cells, 4 times 2 gives us 8 volts. Okay, now, still, before we look at the questions, before we even consider anything else, I want to give you pointers. The first pointer I want you to do is find all your resistors. Find R. Okay, find your resistors. So, go in your question paper and highlight your actual resistors. You'll see we have one here at 0.5 ohms, here at 3 ohms, and here at 6 ohms. Alright? And the reason we do that is because now we can look at the second point where we say follow your current. Alright, we need to understand what's happening in this circuit. So we need to follow the current. Now, how do you know how to follow the current? Like, where does the current go? The current will seek the resistor. Seeks resistance. Okay? So what that means is as current is coming out of the battery, it's not going to shoot up here to the voltmeter, no. Voltmeter just measures potential difference. Your current is going to come along here, okay, just imagine the switch is closed. It's going to go through the ammeter, through this resistor, and then it's going to split here to go to 3 and 6 separately. So, because all the current shoots through the resistor 0.5 ohms, that means this is connected in series in the circuit. And because the current splits right and left here, that means 3 and 6 are connected in parallel to each other. Alright? So that's like the best thing I can teach you in this whole video is those 2 points. Find all your resistors, follow your current. And you're going to see as we go through this question paper, we are going to use Ohm's law for most things. But let's start off with the introduction level question that they usually ask. They'll say to you, if this switch S is open, calculate the value of, and then they give you 3 things there. Your ammeter reading A. Okay, so let's just quickly discuss this. If current comes out of the battery and the switch is open, it can't go further, so A is going to have a reading of 0 amps. Alright? Then we move on to V1. Okay, V1 is the reading on our battery. V1 is basically your EMF to grade 11s and 12s. Okay, now if the switch is open, that just means that V1 measures the total strength of the battery, which would be 8 volts, the potential difference. So it means the battery is giving out a potential of 8 volts here, and over here, well, it's measuring 0, so 8 minus 0, 8 volts. Okay, and now they want V2. Now, if the switch is open, remember the main thing here, the switch is open, meaning no current flows through here at all. And if we had to consider Ohm's law, which we are going to do for most things, V equals I times R. If the switch is open, there is 0 current times whatever the resistance, that means 0 volts. So V2 over there would be 0 volts. Okay. That is generally going to be your introduction level question. There will be 1 mark each. Let's move on to something more difficult. Now the question is going to ask you, cool, switch is closed. Please find the effective resistance. Now, if you don't know how to get the effective resistance, please pause this video and go and check out on the Whiteboard Tutoring, or the Whiteboard SA, the channel. We have a video aimed at effective resistance alone. And from that video, we had the summary. Number 1, tackle RP first. And then the second point was usual formula, R total equals R series plus R parallel. Now, if we take a look here, we can see 3 and 6 are connected in parallel. So therefore 1 over Rp equals 1 over R2 plus 1 over R3. Why? If you had to label these, this is R1, R2, R3. Okay, and substituting in, we get 1 over 3 plus 1 over 6, and that would equal 2 over 6 plus 1 over 6 is 3 over 6. However, this is equals to 1 over Rp. To get Rp alone, we do that flippy flip trick. So Rp over 1, if you had to flip these, you could flip those, is equals to 6 over 3, which means Rp equals 2 ohms. The effective resistance over here, if that had to combine into one resistor, would be 2 ohms. But that's not what they asked for. They asked for the effective resistance of the whole circuit. So now we can look at R total. R total equals R series plus R parallel. What was the resistance in series? It was 0.5 ohms. So we have a half plus 2 equals 2.5 ohms. Okay, let's move on. Next question. Switch is still closed. Most questions from here on out will be based on a closed switch. Okay, the switch is closed. They gave the circuit and they asked us to please find the reading on the ammeter. Pretty please. Now, this is where I introduce you to a really cool thing in electrical circuits. We get a triangle with the formula for Ohm's law. Now, Ohm's law is V equals I times R, right? So V equals I times R. And they want the reading on an ammeter, so they want I, which means I is equals to V over R. Okay, now we just calculated in the previous question, we just calculated R total, right? R total was equals to 2.5 ohms. We know the total voltage on our battery, V total, is equals to 8 volts. That was something we looked at earlier. That was 8 volts. So if we want the current here going through here, can you see it's the current, the total current coming out of the battery? It's the total amount of current that can go through this wire is what's going through ammeter A over there. So therefore we are looking for I total, which is V total divided by R total. So that would be 8 divided by 2.5, which would simplify to, using our calculator, 3.2 amps. Please do not forget your unit. It's so important. Alright, let's push on. So now we get our third question. The switch S is still closed, like I promised. And then I want the reading on V2. Okay? Now, very, very important. Before we even look at this, let's look at where V2 is connected. Because why? When in doubt, we always look at Ohm's law. But Ohm's law is specific to the different connections. Alright, so to understand what we want at V, we need to look where it's connected. Okay, what's the current coming through here? The current coming at that point over there is I total. Let's just write that in. As the current shoots past here, what is involved over there is I total. Alright, and V is connected over this resistance over here. But that is R parallel because it's got both the 3 and the 6 in it. Alright, so to get V2, we can say I total multiplied R parallel, which is, we calculated I total in the previous question, it was 3.2 amps, multiplied R parallel, we calculated in the first question over there, and that was 2 ohms, and that would give you a value of 6.4. What are we looking for? V, so it's volts. Cool. Moving on. Now, switch is still closed. Calculate the amount of heat. Ooh. Okay, Ohm's law might not help us with this, but let's check. Heat is either energy or, in this case, work. One of the two. But let's take a look. Produced by the 3 ohm resistor in 5 minutes. So let's just quickly see. They gave us time, R, and they want heat. Let's take a second to consider the equations that we have to work with. Alright, so firstly, we always write down Ohm's law, V equals I times R, And then we get another two triangles for voltage and current alike. And what we can see is we have volts over here in the bottom. We have volt in Ohm's law, we have volts over there. Then we have current over here, we have current over here. We have charge, and time and time. So let's go through a checklist to see what we have and what we need. Alright? We are looking at the 3 ohm resistor over here. Okay, which means we need to focus on this branch alone. Okay, let's circle it. Do we have the voltage on that branch? Well, because it's connected in parallel to the 6 ohm and V2 was the reading over there, then yes, we technically do. The voltage would equal V2. Do we have the current? No, we do not have the current through the 3 ohm resistance. We have I total, but we don't know how it splits. Alright? What else do we have over there? So let's just quickly tick this off. We know we definitely have the voltage. We've got the resistance itself. We do not have current. They want work, so that's the whole point of the problem. Do we have charge? No, we don't have charge. We said we have volt over there. Okay, now we are looking over here. What else do we have? They gave us time. But again, we do not have charge and we do not have current. Okay, let's take a look. Is there somewhere where we have two things to get work? No, there is not. But we can get current. We can solve current. We can substitute current in there. Then we can get charge, and we can substitute charge in there, and we can find work. Alright, so let's do exactly that. And just take a peek there. V2 was 6.4 volts. Okay. So now write this down. V2 was equal 6.4 volts. Because I have the memory of a goldfish. Okay, so starting over there, we need to get current. I equals V over R. We're going to solve that. Then, what did we say we needed? We needed charge, which would equal I times time. And then, what the point of this was actually to get work, which is equals to voltage times charge. Alright, so we are going to follow this system. V 6.4 volts divided by your resistance, which is 3. And that equals to, using your calculator, you get the voltage as, the current as 2.13 amps. Cool, now we move on to, we need to use that current in our formula up there. So Q equals 2.13 amps multiplied our time. Please remember time is in seconds. So even though it's 5 minutes, it needs to be times 60 to get seconds. Alright, and that gives us a value of 640. 640 what? Well, it's Q, so coulombs. Now we substitute that in there. And remember, we're looking for heat, which is work. It's energy. Alright, so we have voltage, which is supposed to be 6.4 multiplied 640. And you get an answer of 4096. 4096 joules. Alright, we have one more question. And this is the distinction level question. It's what separates those who sort of understand the subject from those who completely don't. Alright. They say switch is still closed, and if another resistor is to be added to the circuit connected in series, that's very, very important, connected in series to what? The 3 ohm resistor. What will happen to the ammeter reading? What they are asking you is figure out what's cracking with R and compare it using your relationship to current. Now, what you need to understand here, very quick explanation, is resistance is indirectly proportional to current. If current had to increase, resistance would decrease. So current over there, if that had to go up, resistance would actually become less. Why? Let me ask you this. What's bigger than between a half and, let's say, an eighth? Well, a half, if you had to go solve that, was 0.5. And an eighth is 0.125. So we can see 0.5 is much bigger than that. But 2 is smaller than 8. So that means if you have a fraction, if the denominator gets bigger, the value of the entire sum becomes smaller. Alright? And that's the same between resistance and current. If current had to increase, the total resistance would decrease. Okay, but we need to look here. They're telling us if we add a resistor in series to this 3 ohm resistor over here, what's going to happen? Well, when you get this, try it out. Imagine a number here for this resistance. I'm just going to make it 2 ohms. And let's see what happens. Alright, so we need to evaluate R total to compare it to I total. So let's calculate R total if this is 2. Okay, and again we need to start off with our parallel first. Okay, 1 over R2 plus 1 over R3. But remember, R2 over here is first going to be the sum of these two together. So that means this is going to become 1 over 3 plus 2 is 5 plus 1 over 6. And now we have a different ball game. Alright, for the sake of time, I'm just going to use a calculator. 1 over 5 plus 1 over 6 would give us the value of 11 over 30. 11 over 30. And then, again, we know this. RP is that flipped over, it becomes 30 over 11, which is actually equals to 2.72. 2.72 ohms. Okay, so your R parallel has become 2.72. What was it before? Before we added that thing, R parallel was actually 2 ohms. So it became greater now. Your R parallel became greater. And remember, R total is actually equals to R series plus R parallel, which would be 0.5 plus 2.72, should be 3.22 ohms. So your R total has actually increased, which means what happens to the current? Your current has decreased. So your answer to this would actually be, therefore current would decrease. Okay, decrease. Okay, ladies and gentlemen, thank you so much for watching. Please like, subscribe and share and become part of our family, and have a fantastic evening. Bye bye.